Okay, so for this example, we're going to go and find the equilibrium point for a system that is not homogeneous. It's actually going to be a non-homogeneous system, so therefore we have some technical issues to deal with. And so we're going to find the equilibrium, and then we're going to study its stability. So an equilibrium point, of course, means that there is no change in the system, so both the x prime is equal to 0 and y prime is equal to 0. And this quickly turns into a 2x2 linear system that we can solve. Negative 4x plus 2y plus 8 is equal to 0. And x minus 2y plus 1 is equal to 0. And we can actually solve for y very quickly by just going in and adding these two equations together. That's going to give us negative 3x. The y's are going to cancel. Plus 9 is equal to 0. So negative 3x equals negative 9, and that makes x equal to 3. And then we can go in and solve for y by plugging the x into either equation. Let's take the second one. It's a little easier. So that's 3. All right, and then with that value of x, we can go in and we can substitute into the first or second equation. The second one's a little easier, and that's going to give us 3 minus 2y plus 1 equals 0, or 4 minus 2y equals 0. So 2y equals 4, and that makes y equal to 2. So our equilibrium point is the ordered pair 3, 2. And now we can't go in and just find the eigenvalues at this point. We have to go and do a change of variable. So what we're going to do is we're going to let u represent x minus 3 and v represent y minus 2. So of course that also implies that x is equal to then u plus 3 and the y is equal to v plus 2. If we take derivatives, we see that x prime and u prime are exactly the same. And we see that y prime and v prime are exactly the same. So now we can go back to our system up here and rewrite it. And that would be x prime being replaced with u prime. And that's equal to negative 4 times the x, which is now u plus 3, plus the 2 times the y, which is v plus 2, plus 8. And then v prime is equal to the x, which again is u plus 3, minus 2 times the y, which is v plus 2, plus 1. And then if we go and expand this out and simplify it down, we should see some really nice cancellations. We've got negative 4u minus 12 plus 2v plus 4 plus 8, and the second one is u plus 3 minus 2v minus 4 plus 1, and you will notice that the constants cancel out in that equation, and for both of them. So our new system is going to be u prime is equal to just negative 4 times u plus 2 times v, and then v prime is now equal to positive u minus 2v. And then in the next part of the video, we'll go in and find the eigenvalues and classify the stability of 3, 2.